point. We then go with that to a handful of folks that are both experts and non-experts in the field. Super important thing if you're going to practice this kind of work is that experts actually are not the people who are going to give you an idea of how to do things dramatically differently, because they became experts by already doing something dramatically differently, and now they're defending their territory. So if you go to talk to somebody and say, can this be done out here? Most people we talk to, they can tell you precisely why it can't be done, which is really valuable from a selection pressure standpoint, but not the source of kind of, and here's a completely different way. So other people, though, who don't have expertise but have interesting creativity, so what we do is we take our hypotheses, and it's never one, because one of the things we've learned is that if you start with one starting point, you only locally search the space around it. So we sample multiple different points. So it might be, how about mRNA as a way to make more proteins in a fermenter? How about, so around the theme, we come up with totally different value pools we try to identify. And then we put a starting point, and then we start talking. And what's been interesting and a great learning exercise over the years that we've seen is that if you go to somebody with a bad idea, but you actually present it in a precise way, they will tell you why it's a bad idea. And in that transaction, something happens, they feel smarter, and you get selection pressure. And so the way our process works is that we actually do this with multiple people. So when you said, aren't you afraid they're going to take your idea? What are they taking? We just made it up. There's zero fact to it. Literally zero fact.
You're just imagining it.
Exactly. We're just a hypothesis. And they know it. Because then they tell us, what proof do you have? I say, none. So then they still engage, because it's almost, when we talk to these folks, and this is what we're known for, we create a bit of an expert-free zone, in the sense that look, these scientists, here we are at Harvard and MIT, Stanford, these people go to the meetings of their fields, and they cannot say something that does not seem unbelievably smart and reasonable. Actually, I'll make the point, let me caveat. Reasonableness, in my view, is like the gravitational force that keeps innovation from happening. Because people enforce reasonableness in the scientific world on what you are allowed to say. You go publish something in literature that's not reasonable to the reviewers, you can't publish it.
You're killed. I've done a whole study on that.
Right. So ask yourself the question, why is it that we think that the only innovations worth working on start their life reasonably? In fact, I can show you many innovations that are now accepted as real transformative things. Every one of them started life unreasonably. And yet, we go look for them in reasonable places by reasonable people who are using reasonableness filters to kill them. So because we knew that, this was not the first thing I had done, we kind of say, look, let's forget reasonableness for a second, just think with us. And they tell us, bad idea, somebody in Japan had tried it, experiment won't work. And we keep tweaking and tweaking and tweaking. This is different than kind of like you hear a lot in Silicon Valley speak, kind of pivoting. This is not pivoting. Evolution is the master pivot. It's like non-stop pivoting, right? There's nothing to pivot from and to. You're just adapting and surviving. So that mindset is super important. Now, what happens is over time, things emerge, or they don't, but they emerge where the next person you talk to goes, they can't find fault with it. You know that because it frustrates them. And then they start telling you, well, do you have any proof? And you go, no, I just made this up. It's just that we've been iterating. And then that point is when we go into a lab for the first time. And then and only